All right. Hey, everyone tuning in. This is the first episode of the ICC podcast, where we plan to meet with various ICC members to discuss all things computing. From my limited perspective of the city, Houghton has an affinity for interesting and smart people. And on that note, I want to introduce our first guest of the podcast, Tim Havens. Foremost, he is a Grateful Dead fan and also a musical artist himself. Tim manages to find a little bit of his spare time to be the director of both the Institute of Computing and Cybersystems and the Great Lakes Research Center, as well as being a William and Gloria Jackson endowed professor and part of the M2 Enterprise program. So with all that being said, hi, Tim. Welcome to the podcast.
Thanks, James. I'm glad you mentioned the Grateful Dead fan first. You know, that's very important.
Oh, yeah. I figured that was at the forefront. And excited to jump into the interesting stuff we have to talk about today. So to open, I just wanted to know if you could provide kind of a general overview of your current areas of research.
Sure. So at this point in my career, you know, my research portfolio has gotten pretty diverse. I have very big teams that I work with in both the Institute of Computing and Cybersystems and the Great Lakes Research Center. So I have research that's pretty broad in application area. I'm doing everything from high frequency radars that sense surface currents in the Great Lakes, all the way to military applications of artificial intelligence, and specifically for like synthetic aperture radar and imaging systems. So I'm doing a lot of different things. I work with a lot of different types of researchers in a lot of different fields, and it's really exciting for me. And I think that's my happy place, when I get to be involved with a lot of different types of projects in a different way.
Yeah, and that's a great segue because, you know, in your work, you mentioned you're constantly collaborating, often with individuals with different fields as yourself or different, backgrounds, which enforces kind of what we do at the ICC, the interdisciplinary collaboration. And, the outcomes of interdisciplinary research have been, heavily touted. So I guess, do you have any approaches or strategies on surrounding yourself with the right people from different fields to support each other's research?
Yeah, and I think that my philosophy probably comes from a lot of my younger musical training, where I was playing in large musical organizations, big bands, smaller jazz bands, big orchestras, and those kinds of things. And you really have to be synchronized, with that group of people in order to produce good music. And so a lot of it is like, how do you grow together? How do you practice together? How do you learn how each other plays? How do you listen to the others so that you all stay in sync? And it becomes kind of a community, where it's not just about the music, but it's about your relationships with each other. And often, I find that like the best bands in the world are also the ones that are the closest community-wise, and friendships and those kinds of things, because that comes through in the art. And so I think that has kind of driven the way that I think about putting together teams, because once we're comfortably fed and sheltered, we all just want to be supported, challenged, happy. So my philosophy really in building teams is to first build something that people want to be a part of. And so that could be as simple as an individual, like starting the seed of something exciting and being passionate about it. And then, you start to find like-minded individuals and start working with them. And then once you have something that is moving forward and you're starting to develop this mass, I mean, you just start telling everybody about it. I think it's just kind of a natural about, what we do in the world as humans and the work that we do. And so great people tend to find you after that starts happening, because they want to be, a part of this fun, great thing that's happening. And so if you think about it, really all of us are on both sides of this fence pretty much all the time. Like sometimes we're trying to recruit other people into this team that we're on, so that we can do bigger, more impactful things. And then sometimes we find ourselves moving to a new situation that attracts us, and it kind of breaks up the whole formation of the universe. And so really, I see it as it's, surrounding yourself with the right people is like the formation of galaxies and planetary systems. It's like mass attracts people. And so that mass really is like doing fun, great, impactful things. And so then now I find myself in a situation where I'm leading these big organizations. And so really my philosophy to attract the right people at this point and do the great things that we're doing is give people the time, tools, and motivation to do these great things. And, the greatness tends to follow.
Cool. And do you feel like, these interdisciplinary collaborations where you have these close teams and this big mass that kind of come together and, create the desired outcome? Do you think it enhances the outcomes tremendously from projects in the past where you've had a less diverse team?
Oh, absolutely. I think the data don't lie, right? And that might be a reoccurring theme and why I talk about a lot. I'm definitely a data person, but there's been a lot of research about how to build effective teams. And a lot of this research actually comes out of the military, because that's a place where like you need to have a cohesive, effective team to win, if you will. But we've seen a lot of this coming out of cognitive sciences, and we have people at Michigan Tech that are studying this, and the data overwhelmingly supports that diverse teams perform at a higher level than those that are not diverse. And so you can apply that more of a microcosm to discipline, is that when you have an interdisciplinary team, it really enhances the outcomes of the research, because you can have people that are experts in each of the necessary fields. And if they can communicate with each other, then all of a sudden everybody's learning something, everybody's thinking about what they're doing in a different framework. And that's when the really great stuff happens. I mean, really grand challenges are not solved by individuals. We put together teams of experts that not only have the deep knowledge of their discipline, but also that ability to communicate across disciplines. And I can't tell you, the number of times that I've had ideas about a problem that I've been thinking about for a really long time on my own, sitting in bed at night, looking at the ceiling. And then all of a sudden, someday you're forced to reframe your thoughts and talk to somebody about that. And then it really forces you to think about it differently yourself. And then boom, a new idea comes, which could really catalyze like an entire 5-year project out of that new conversation. So really, have as many conversations with people as you can about what you're working on, because it'll probably benefit your research. And so another thing too is like, it's really, really fun to learn new things about the world. And that's why I'm in the academic business, is like it's part of the job. And I think most people think that way. And by working on interdisciplinary teams, you're constantly learning new stuff. It's super fun.
When you have a team of people who are super interested in different topics and areas, have you gotten better at communicating with these people over, like, different people over time from different backgrounds? Has that been a skill set you've developed?
Most definitely. I think there was I'm thinking of a conversation that I had when I first came to Michigan Tech 12 years ago, and I went out to lunch with somebody that I played music with when I was a student here at Michigan Tech, and he had gone one direction in his career and was doing like computer IT stuff, and I'd gone a different direction in my career, and we were kind of talking about like, what is it that have allowed us to come to the places that we were at? And we both realized that the skill that has really brought us to the success that we've had is the ability to talk about what we're doing, and to talk to people that are both experts in the field and what you're doing. So having those deep conversations about the particulars of the problem and express them in a way that you can efficiently solve problems together, but then also that ability to talk about what you're doing to an audience that may not have any scientific or math training or whatever the deep knowledge in your field that's required to actually perform it is, and express it in a way that they can understand what you're doing and bring something to the table of their own to help you solve that problem or give you new perspective on what that is.
And when you're talking with these people that give, they bring their own thing to the table and it's a very different skill set, is there any specific collaboration you've had that has resulted in a major shift about how you think about a certain field or topic?
Yeah, well, and I think that this is like one of the big things that I really seek out in collaborating with new people, because I feel as though we are all just products of the people that have been around us in our lives. And so really every collaboration that I've had has caused that kind of major shifts in the way I think about things. And each one is different. Like some people have taught me new ways to present my work, to get ideas across. Some people have changed the way I think about like cultivating relationships. And I've seen people that are actually absolute experts at just building strong relationships with people and having them trust you to move forward and solve problems. And really, other people I've worked with have been more inspiring in, say, the way that they work or the way that they solve problems, the way that their math expertise, whatever it happens to be. And so I think everybody has something to offer. And so when you build these collaborations, I think you become a better person yourself through these. And we're all an amalgam of the people who have affected us, good and bad along the way. And, I've been really lucky to work with some great people. From the time I was an undergraduate student at Michigan Tech to I was uh, the technical staff at MIT Lincoln Laboratories, which was a pretty formative experience. And up until now, where I work with these institute-sized teams all the time, there's just fantastic people everywhere to learn from. And really, there's a few people that I can think of that in particular, as I talk about this. And, one person that was really influential in the way I approach problems was somebody in my first job out of college. So his name was Shu Han, and he was technical staff at MIT Lincoln Labs. And so this was my first job out of my master's degree at Michigan Tech. Um, Went into this new place, Boston, Massachusetts, and this new institution. I was very intimidated, being a Michigan Tech person going to work at Massachusetts Institute of Technology, the top of the hill.
Mhm.
And he and I we worked together on this problem, and he kind of became my mentor. And he was a brilliant scientist, or I'm sure he is a brilliant scientist. And in retrospect, it's interesting because as an educator, I look back and I realize also like how patient he was with me, and because I was somebody at the time who I really just wanted to like race to the end of a problem. I wanted to solve it fast. I was somebody who was always really good at school. I was usually the first person done with tests, and um, maybe not the highest score, but darn good enough to get an A. But I wanted to be first and call it solved and move on. And he was the complete opposite. He was like, that's great. I'm really glad that you solved this problem. But what about all this and why? And so he'd ask all these questions, which I didn't necessarily have the answers to. And there was some young person frustration there. I was like, but I solved it. And so he really like taught me like how to break problems down to their most basic fundamentals, like really, really go simple. And when you thought you had gone as simple as it could go, like he would just break it down further. Um, and he took a very meticulous and thorough approach to understanding complicated systems. And we were working on very, very complicated systems. And so by the time I got done like working with him after the 5 years that I'd been there, like I realized that, there was I had this really, really deep understanding of how these systems worked and had learned so much math and so much computer science and analytical tools and statistics simply because like he was always asking the fundamental questions of how things worked. And we did great work, and we always knew why things worked the way they did and could identify problems fast. And so it's vital to understand not only to how to solve the problem, but why that thing is that you create actually works. And that's really informed the way that I have become an educator at Michigan Tech. I think there isn't a student at Tech that I've worked with who hasn't heard me ask, like, what's the simplest version of this problem? How can you break it down further? And is that really the simplest version? Because if you can't solve the simple version, even if it takes 5 minutes, you know, then you're probably not ready to move on to the complicated one. And so Shu was always someone who always, brought it back to the fundamentals, brought it back to the math, and I really appreciate him for that. He was very formative in my experience. And so I'm still to this day like kind of a transformed person, because I now feel that way because I'm more comfortable when you can bring those problems back into like the mathematical space, the fundamental space. And so he was very inspiring.
Yeah, it's crazy the amount of difference that a good advisor or a good lead can do. And my cat's agreeing too here in the corner. But uh to maybe I guess take away the human aspect now to segue, during my last, or not my last visit, but two visits ago when I was there in October, we had kind of a funny, interesting conversation with some of our event guests about the capabilities of ChatGPT. And I think we actually confirmed that ChatGPT does know who you are. So congratulations on that. Uh, but going off of this, I was curious to know what role generative AI tools play in your proposals and projects. Do you kind of use them for project management, data analysis? Where does this kind of come into play?
Well, I will go on record in saying that I am a heavy user of ChatGPT. I absolutely love it. It's good at some things, it's terrible at other things, and even when it's terrible at things, I think it's kind of funny. But it's a really, really good tool. And a lot of the generative AI tools are really, really good. And we've kind of been involved with generative AI in my research since, they first started coming out, because one of the things that we're really interested in is like, how do you train machine learning algorithms when you don't have the data to train them with? So let's say you just have like one photograph of a thing that you want to detect. Like, how do you train a machine learning algorithm to detect that? And the answer is really, you can with one photograph. And so we've been studying ways that you can do that. And so that's where like generative AI, starting from the beginning of the GANs, and these really basic algorithms that we thought that they produced really cool images then. Little did we know that 5 years later, that things that you could go on a website and immediately get like photorealistic images of giant cats, eating string cheese while sitting on top of a skyscraper would be possible. I Not that I've ever created that image. I mean, lots of cat images, I will tell you. And so we've been thinking about this for a while, and how you use generative AI, how you use synthetic data tools to train machine learning algorithms. And then you really get into, strange questions of just, if you're training machine learning with machine learning, what does that mean? And I don't think anybody really knows the answer, but I kind of really see generative AI as just another simulation tool. But rather than explicitly stringing together physics-based equations and approximation techniques and optimizations and statistics, you're building a neural network that implicitly learns how the world works in those ways, albeit in a very narrow way that maybe suits just one purpose. But it's learning those physics because you're just presenting it with a whole bunch of instances that it can learn from. So it's definitely a big piece of the research that I do.
And is there any like unique challenges that come from using this, especially when it maybe deals with sensitive data or, certain other pitfalls to having generative AI that may, use your data for other purposes, or I don't know what other pitfalls might come from that?
Yeah, well, and I'll answer this question in two different ways. First is like, as an educator, generative AI has certainly upset the apple cart. I would say, if in the 12 years that I've been a full-time educator, and I even taught before that as a graduate student, there really hasn't been something that has come along that has been nearly as disruptive as generative AI. There were things like, online repositories of papers that people could download, or the websites where you could go and you could pay somebody to write your essay, a few dollars, and do your work. Those things kind of always existed. But generative AI is completely different. It's astonishing. Like, I can go to ChatGPT, type in a prompt, and immediately get a pretty convincing essay that I could turn in and probably get an A in a lot of college classes. Now, I think most educators have gotten pretty good at detecting when that's being done, because you get to know the person as much as you get to know the work. And you start to see that especially ChatGPT is pretty monotonic in the way that it writes. But it really invites a huge problem for education, right? Because the barrier for violating academic integrity is like nearly demolished Like before, I had to go out and I had to pay somebody a few bucks and have them write my paper. It involved another person, and maybe that person could turn me in. And, I think when we involve other people, like our ethics level naturally rises because, none of us, I don't think, want to be bad people. We all want to do good. But when it comes to just typing something into an app on your phone, I think that that's a very different thing. And so, you know, there's no witnesses. I can just download the paper and I can turn it in. And so that's really the big challenge. And so I don't think it's necessarily the challenge that generative AI is. It's the challenge that boils down to how we value truthfulness and authenticity as a society. So one thing I like about all this discussion is that it really brings to the forefront some really basic questions about how we rethink our education system to value and incentivize like true learning of deep knowledge, like how we assess that learned knowledge in the individuals that we're teaching. It's not just about the truthfulness and authenticity of the learners. I mean, it is on them. Like academic integrity ultimately is on the learner, right? You're there to learn. You're there to become really good at something. You're paying for it. So that's what you should do. And so, yeah, follow academic integrity because that's the thing that's going to help you the most in your future. But it's also on the institution at this point, because are we being truthful with ourselves when we give someone a degree? Have they learned what we want them to learn? And so I think generative AI has really forced us to reconcile with that question, and so how do we assess that somebody has learned what they need to learn? How do we change our education style so that we can make sure that when somebody gets a degree that says that they know electrical engineering, that they know electrical engineering and go out into the workforce and be a really effective electrical engineer, that the plane continues to fly, as I always like to say. And I think this just scratches the surface of the challenges that generative AI brings to education and the world in general. There's the accuracy of AI. I think a lot of students are starting to catch on to this, that at first, like when students were using generative AI, we could tell really fast because there'd be like fake citations and weird facts that didn't make sense. But what about the ethics of using it? How do we teach students that ethics are just as important as performance? The environmental impact. Let's think about like how much energy it takes every time we generate a picture of a cat eating cheese on top of a skyscraper. And do we really need to do that? Probably not. Bias, there's a lot of bias in these algorithms. Diversity, the list is so long. And so you also asked the question about like sensitivity of data and projects. So, all universities do work with the Department of Defense, with DARPA, with these organizations that have sensitive data. Health data, is a big one. And so how do we make sure that we're keeping sensitive data sensitive and private, and at the same time explore the use of generative AI? And so on one hand, I kind of view generative AI and large language models to be specific as a person. Like first, when it comes to sensitive data, just think about them as a person, and you shouldn't tell that person about what you're doing. So don't put sensitive data into ChatGPT. That's simple. At the same time, it's also not that simple, right? Because there's a lot of research questions out there about the use of AI for sensitive purposes, whether it's health or military purposes. And so how do we explore simultaneously the use of these algorithms that could potentially change, for positive outcomes? Like, if we could detect cancer much, 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 much earlier, then perhaps we could save a lot of lives. So how do we ensure the algorithms are stable and robust? The only way we can do that is to use the algorithms. So how do we make sure that there isn't some backdoor attack in these algorithms that we download off the internet? Because these are algorithms with millions and millions and millions of numbers in them. How do we ensure that there isn't something baked in there that we create something that can detect a vehicle, but all that somebody needs to do is wrap that vehicle in some funky pattern and you can't detect it anymore, and your self-driving car now just runs into it? So there's a lot of really tough questions that we need to answer. And so I don't have the answers. They're really tough. But I think that we need to continue to investigate how we can use sensitive data with generative AI tools, and ensure that those sensitive data remain private.
And they're constantly evolving anyways, and you have to keep up with it too. And it's a good segue that you brought up the car, because I wanted to ask you about, the autonomous systems projects you've undertaken. And the GLRC has a lot of cool toys. Have you been involved with any of the development of the autonomous systems there, like the Wave Runner, the Buoy network?
First of all, the GLRC does not have toys. We have resources and systems that are very serious. They're really fun though, so I'll give that to you. Yeah, so we've become experts in the use of autonomy, both application-based, which I would say is most of our work. So using autonomous systems that others have built to answer questions about our world, whether it's our underwater ecosystems, fisheries, biology, our water quality, things like that. So we have underwater vehicles that we use that can completely autonomously go down, collect a bunch of data, pop back up. We collect that data and then gain the knowledge from the analysis of those data. We have underwater autonomous vehicles that can stay down months at a time using buoyancy, as their energy source, just kind of bouncing around in the water column. We've used those to read fish tags and take other types of measurements. We have autonomous systems to use the power of waves to move around. So they're not very fast, but they can stay out for months at a time and collect data. We've used those to collect chlorophyll data from regions around some places in Lake Superior, and those are fun. And then I have a Navy project right now that I have a couple PhD students that are working on, where they're developing a autonomous surface vehicle, and they're examining the questions around robust autonomy. So how do we always ensure that an autonomous system acts properly when things go wrong? So let's say there's fog on the water, or there's a lot of waves, or there's a lot of wind, or the sun is shining into the camera. So those are some examples. Or let's say there's a person, like somebody out there in their boat who's harassing the autonomous vehicle. Can we make sure that the autonomous vehicle stays doing what it's supposed to be in a safe manner? So we're working with the Navy on that. So a lot of fun things that we're doing with autonomy.
Cool. And it's a good kind of question to always ask when it comes to autonomy, is what kind of measures are taken by you or your colleagues to ensure that, there's the ethical development and deployment of these systems? What kind of guardrails do these systems have?
Yeah, so there's a lot of guardrails that exist in autonomy. I think we're all familiar with the boundaries that are put on UAVs around airports. And at this point, when you buy a UAV from one of the major vendors, like, it's nearly impossible to push it beyond those guardrails, because they're built into the control system. And I think we have the same thing with our vehicles. We have safety protocols built into them automatically, so that for example, let's say that we have an underwater vehicle that's running low on power. Well, it'll stop its mission and come to the surface, so that it's not polluting the water and we have to go find it and potentially put divers at risk. In our surface vehicles, we have things like AIS and collision avoidance, so it automatically interrogates the boat positioning systems that exist in large vessels and then gets out of the way, so the vessels don't even need to think about it. So we're always trying to think about what are the things that could go wrong, and how do we mitigate those situations. And one of the big efforts that we have is the Smart Ships Coalition, which was started a few years ago by the Great Lakes Research Center. And this is a group of about 70 organizations at this point: government, industry, and academic organizations. And we get together once a year for a conference, and we discuss everything smart ships. So what does it mean to be a smart ship? What is the technology that's coming out in the future? What are the crews going to look like on smart ships? And how do we make sure that those crews stay safe? How do we make sure the smart ships aren't going to run into each other or into bridges or other infrastructure and things like that? So we're having this conversation with the Coast Guard, with shipping companies, and with leading academics in this, just so that as this technology starts to be fielded, which it will, it's done in a safe way.
Yeah, and I'd like to get into your personal thoughts a little bit as we get closer to wrapping this up here. Is, you've worked with a lot of autonomous decision making, and you've probably likely mulled over the positive and negatives of a lot of this technology. And it's a human probably thing to mistrust technology. Like, there's a lot of movies like iRobot, and this media exists from this established fear of this technology that humans have. But I guess, do you have any grabbing thoughts that on the contemporary state of the field and its possibilities and its pitfalls?
Well, I think that the potential for positive impact on the universe of autonomy and artificial intelligence is strong. I view artificial intelligence and autonomy as a natural progression of humans seeking tools that allow us to be more efficient in solving the problems that are in front of us related to the survival of our species and our planet and everything around us. So I'm a strong advocate of technology and believe that when it really comes down to it, that humans have our best interest at heart, and hopefully that means the interest of the planet and all its species and the universe that surrounds us. Um, so I see good things. At the same time, I think we need to think about these pitfalls, and we can't just ignore them. We need to talk about them. We need to have people that are there to let us know when we're going astray and not thinking about things. And there are a lot of researchers at Michigan Tech that are examining this exact question of ethics and pitfalls of autonomy and AI. And to give you an example, Michigan Tech recently stood up a task force to investigate the use of AI in our across-the-board curriculum at Michigan Tech, to be able to investigate the questions of not only, how should we be using AI in our curriculum, but how can we ensure that students are getting the best experience possible and learning the things that they need to learn at the same time, living in an AI world. The vice president of research at Michigan Tech released a policy on the use of large language model generative AI tools in research activities, specifically outlining things like sensitive data and the such. Many departments have enacted guidelines that you can find online about the use of generative AI, where it should be used and where it shouldn't be used, how to best use it and how to not best use it. One institute at Michigan Tech that I think is at the forefront of this is the Institute of Policy, Ethics, and Culture. So as an institute, they investigate the questions, obviously, of ethics and culture. And so there's been some great books that have come out of some of the researchers looking at the effects of algorithms on society, and what that means for the progression of our society as a whole. And recently, this institute and the Institute of Computing and Cybersystems submitted a proposal to build a Center for Humanistic AI research at Michigan Tech. So we really want to put together different disciplines to study these grand challenges of AI and its use, and fingers crossed on it getting funded. So, in a nutshell, I'm a technology proponent, so that's my bias. And so I don't see generative AI and autonomy as being the ethical challenge in itself. I think instead, like most technologies, these technologies have destroyed some of the guardrails we have. They make it easier for individuals to perform unethical actions and big unethical actions. So, like a lot of the powerful technologies before them, like we need to identify the potential ethical challenges, talk about them, and then provide subsequent incentives for society to continue to progress ethically.
Yeah. And that's good to hear because you are a subject matter expert in the field. So I guess to circle back around, how did you get the interest to pursue these? Were you originally kind of studying this kind of field, or did you transition to doing this later in your career?
Well, I think that we all live a few different lives, right? In the beginning of my career, when I was here, so I did my undergraduate and master's at Michigan Tech, and I studied statistical signal processing. So it was all about like, how do we come up with statistically optimal ways of describing the behavior of signals in systems. So the electrical signals that come from cameras, the electrical signals that come from communication devices, things like that. So it was almost like the opposite of machine learning and AI, in that everything was almost very exacting. You boil things down to exact equations, and that's what you're seeking. And then when I went to MIT Lincoln Labs, it was more of the same. They hired me to do that. I was working on directed energy systems and simulating them and trying to determine, like, statistically, what was going to happen with those systems. And in fact, like, when I went to do my PhD, I was going down that same path. I had an advisor chosen. We were going to study the use of satellite-based radar for ice sheet analysis in Antarctica. I was super excited. I thought that I was going to get to go to Antarctica and was really excited about that. I'd been reading a whole bunch of books about, like, Shackleton and people like him. I was certain of my future, absolutely certain, and I think that's maybe an allegory of where I'm going to go next. But when I went to visit the campus at University of Missouri for the first time, I thought, I'm going to walk around the department. I'm going to introduce myself to some other professors and just to get to know them. And after meeting my eventual PhD advisor, Jim Keller, I'll call it like academic love at first sight. Like, we just really clicked. Like, he's a really approachable person. He's really funny. He's really, really smart. He invited me out for a beer right away, just a man after my own heart. But interestingly, like, his field was fuzzy systems, which is like a completely different way of representing uncertainty than statistics and probability. And so my whole academic focus shifted. And so, rather than these statistically optimal tools and probability things that I was doing before, I really dove headlong into, like, fuzzy sets and systems and machine learning and pattern recognition, and then eventually, like, deep learning and neural networks and those kinds of things, like these learning systems, as opposed to these mathematical systems that I was using before, which are very exacting ways of describing the universe. So now I just build big approximation engines at this point.
And do you think having both sides of that coin kind of helps you out a little bit, makes you have a stronger understanding the mathematical side as well as the fuzzy side?
Yes, definitely. And much of my work is informed by both sides of that. Uh, right now, we have a project with the Army where we're looking at the use of AI together with synthetic aperture radar. And I would say, like, that project is mostly on that statistically optimal modeling side. And then we use AI with those statistically optimal models to see what we can do. So it's really combining those two things. But I would say much of my work has been very much informed by my signal processing background.
Cool. Well, we're about out of time here, but I wanted to ask you, is there anything else that I didn't list that you like to do for fun outside of work besides listen to Grateful Dead?
Well, I don't like to just listen to the Grateful Dead.
Oh, you're right.
I also like to play the Grateful Dead. So I am a music lover in all ways. I love listening to music. I love watching music. I love going to concerts, but most of all, I like playing music. So I've played music since I was a young kid, and I've played in all kinds of bands, jazz bands, rock bands, metal bands, big bands, orchestras, you name it. So I would say I spend most of my time outside of work focused on some kind of musical activity. And of course, usually with a cat in my lap, because I absolutely love my two cats, Rick Slade and Jocko.
All right. Well, thank you for coming on today. It was a great conversation. It was great having you on, and yeah, I even learned something. So that was awesome. Thank you so much, Tim.
Thank you, James.